a new approach to the design of a liquid battery using a passive gravity-fed arrangement similar to an old-fashioned hourglass could offer great advantages due to the system's low cost and the simplicity of its design and operation, says a team of MIT researchers who have made a demonstration version of the new battery. Liquid flow batteries, in which the positive and negative electrodes are each in liquid form and separated by a membrane, are not a new concept, and some members of this research team unveiled an earlier concept 3 years ago. The basic technology can use a variety of chemical formulations, including the same chemical compounds found in today's lithium-ion batteries. In this case, key components are not solid slabs that remain in place for the life of the battery, but rather tiny particles that can be carried along in a liquid slurry. Increasing storage capacity simply requires bigger tanks to hold the slurry. But all previous versions of liquid batteries have relied on complex systems of tanks, valves and pumps, adding to the cost and providing multiple opportunities for possible leaks and failures. The new version, which substitutes a simple gravity feed for the pump system, eliminates that complexity. The rate of energy production can be adjusted simply by changing the angle of the device, thus speeding up or slowing down the rate of flow. The original concept for the flow batteries dates back to the 1970s, but the early versions used materials that had very low energy density. That is, they had a low capacity for storing energy in proportion to their weight. A major new step in the development of flow batteries came with the introduction of high energy density versions a few years ago, including one developed by members of this MIT team that used the same chemical compounds as conventional lithium-ion batteries. That version had many advantages but shared with other flow batteries the disadvantage of complexity in its plumbing systems. The new version replaces all that plumbing with a simple gravity-fed system. In principle, it functions like an old hourglass or egg timer, with particles flowing through a narrow opening from one tank to another. The flow can then be reversed by turning the device over. In this case, the overall shape looks more like a rectangular window frame with a narrow slot at the place where two sashes would meet in the middle. The new design should make possible simpler and more compact battery systems, which could be inexpensive and modular, allowing for gradual expansion of grid-connected storage systems to meet growing demand. Such storage systems will be critical for scaling up the use of intermittent power sources such as wind and solar. While a conventional all-solid battery requires electrical connectors for each of the cells that make up a large battery system, in the flow battery, only the small region at the center, the neck of the hourglass, requires these contacts, greatly simplifying the mechanical assembly of the system. The components are simple enough that they could be made through injection molding or even 3D printing.